Hi, I am EMİRHAN KAYABAŞI. I am the system engineer of this project. Let me start with summary. This report outlines the design of a smartphone controller packet size signal analyzer that can analyze signals from 1 Hz to 1 MHz in both time and frequency domains. Let me go on an introduction. Signal analyzers are crucial for measuring and analyzing signals in electronics and communication engineering. This project aims to create a compact, affordable, and user-friendly signal analyzer controlled via smartphone, making advanced signal analysis accessible to hobbies, small business, and educational institutions. Problem statement and need identifications. Problem statement. Existing signal analyzers are not portable, affordable, or easy to use for non-professionals. Need identification, portability, affordability, user-friendly, and versatility. Research, technology survey, and back information. Research. Focus on microcontroller, RF components, ADCs, communication modules, and app development for smartphone integration. Technology survey. Microcontrollers and FPGAs, RF components, ADCs, Bluetooth Wi-Fi modules, and smartphone apps.
I will give you information about our level 0 and 1 design and functional requirements tables. As can be seen, level 0 is the simplest level design. Input signals between 1 Hz and 100 MHz output is displayed on the smartphone. Level 1 design is a little more comprehensive. As can be seen, the incoming signals are first transferred to RF module, then to the ADC, then to the FPGA block, then to the signal analyzer, and finally to the smartphone. This entire system feeds a power supply. In the RF module, the input is signals, the output is the filtered and amplified analog signal. These analog signals become input to the ADC module, and the output in the ADC module is digital signals. Digital signals become input to the FPGA, and the process data becomes output. The process data becomes input on the smartphone, and finally our output is the analysis results. For the battery, the input is the power supply and the output is the regulated voltage.
Hi, I'm going to talk about how the final product is realized. As you see, it's realized is exactly seen from the block diagram. The initial part, which is the part from the antenna to the ADC, analog digital converter, handles the signal in analog form. While after the ADC, it transitions to the digital form. And then the part consisting of FPGA, microcontroller, FFC model, and time domain analysis model are responsible to process the data. In other words, the data are processed on these modules. Then the data goes to the Bluetooth Wi-Fi module. Actually, it simply sends data to the app on the smartphone. Some of the devices selected are seen. Was determined which devices to choose. Actually, we mainly use two methods: the nominal group technique and brainstorming, to be able to determine which option is more valid for us. I mean, we've talked with each other actually. That's all. Thanks for listening to me.
Hello, I'm GÖKAY and software engineer of this team, and I'm going to explain how it works our application with logically. It is our first flowchart. It has several different steps, like start application and goes with the closing application. This is also activity diagram. It's starting with signal capturing, after digital converting, and then signal processing, and finally displaying on mobile app. This class diagram has also 6 different steps with signal analyzer, front end, ADC, MCU, FPGA, power management, and mobile app different classes. This is use case diagram. As you can see, we have 5 different steps like open application, time domain analysis, frequency domain analysis, and change scaling and storing data. This is state machine diagram, initialization, signal capture, processing, idle, visualization, and data transmission. Thanks for watching me.
We'll give brief explanations about the following topics. To verify our design and product, creating and following test plans are crucial. We prefer 4 different types of tests. These are unit, model, functional, and integral tests. Unit test verifies the functionality of individual components such as MCU. Model test validates the functionality of a specific model such as power supply model. Functional test verifies that the system functions as intended such as data storage. Integration test check the interactions between different models such as communication model to mobile application. Preparing a realistic project plan is essential to achieve a successful final product. In this project, we have 3 work packages. The responsible people, durations, and checkpoints are decided carefully to avoid issues like time crunch or overworking. For time management, we also use Gantt chart. Another critical issue for project process is being aware of risks and prepare alternative actions to minimize the negative impacts. The risks we consider are about hardware, data privacy and security, compatibility, and design dimensions. We tackle these risks from the perspective that is preventive actions, probability and impact, and Plan B.
Cost analysis and commercialization plan. Cost analysis, component cost, development cost, production cost, retail pricing. Commercialization plan, market analysis, marketing strategy, distribution channels, customer support. Conclusions. The development of smartphone control, packet size, signal analyzer represent a pivotal advancement in the field of electronics communications technology. This innovative device addresses several key limitations of traditional signal analyzer, offering significant benefits in terms of portability, affordability, and user-friendliness. Thank you for listening us.